All right, so 13.3 is very much related to 13.1, okay? The difference in 13.3 is that the base, which is going to be the B, is going to be the value of E. Oh. So, E is going to be a brand new number. I'm not finished explaining this yet. So, you know how pi is a number on the calculator, right? So pi is 3.1459. Okay, and it's a number that keeps going on forever and ever and ever. Okay, well, E is a number that's just like pi. It's a number that goes on forever, and it has a specific value. Okay, the calculator actually has two separate buttons for the E. Okay, so if you grab a calculator and take a look here.
Press alpha.
No, you do not push alpha E. Okay, the E button is if you hit second divide. Second divide. Yeah.
Is that like
Okay.
a repeating number?
A what?
Is it like a repeating number?
It is not repeating.
Oh, that's it?
It keeps going forever.
How is that possible?
Just like pi.
So the what?
So
Just
E,
because of the 7 in the front, it makes it not a repeating number? Like your regular, you just can't see farther. It goes to change. Oh, it does. How does it change though after the same pattern twice in a row? That's not.
well, it does. It changes. Do you want me to Google it for you?
Yeah, it is. I'll Google it myself.
Hold on, everyone. We have to prove that I'm just not making this up.
Well, I just doesn't make it like normally like when you like a pattern repeats, it's got to repeat
you're
the
right.
whole time.
Mm-hmm.
So I don't understand how you get a different value randomly.
Gotcha. Oh my gosh, come on. I have a pretty good story to tell you guys after I give notes. Speaking of, I don't understand how you don't understand. Like, oh really? That's perfect. I'm gonna tell him you said that. Not you said that, but somebody said that. Oh my gosh. Maybe it would have been faster if you would have Googled it. It's close. Wait for it. It's still spinning. Value V. There we go. There we go. It's too much work for the tablet. Probably because I've Googled the walk a lot of times, because I sometimes eat there.
Oh, it definitely changes.
I like the walk.
It is
So,
like, how
because
do you
it's
get
signed
1828,
into my
1828,
searches.
and it doesn't keep going.
Wait, just
It's
calm
been
down.
calculated to-
Calm down. Hold on.
Yeah, how is that possible?
Yeah. Let's see if we can find. Oh, this is the value of E, just in case you are wondering. It's the summation from 0 to infinity of 1 over the, how do you say that exclamation mark?
Yeah, it doesn't repeat.
Factorial, n to the factorial.
It's got a pattern.
So here it is right here.
I got it.
You see it? So it actually does not repeat. It becomes completely random. So, do we all agree that this is an irrational number?
Yeah.
And cannot be written as a fraction now? And so we are going to call that irrational number E. Okay, so it basically came from, it's a number that's used with exponential ideas. So does it make sense why they use the letter E for exponential ideas?
Or for Euler, they gotta make it. That would make sense.
Okay, Mr. Know-It-All, maybe you should teach it.
I'm just saying, I saw it. It was in the.
Maybe we should just Google it.
Yeah. It was. It was in the Wikipedia.
Maybe I'll sit down and you guys can Google how to do all this.
Okay. I'm just saying.
Okay.
We could.
All right, so see the blue equation that I just highlighted? Does that look very super familiar from the equation you wrote down in the last note?
Yeah.
Like,
Instead of B.
exactly. Okay, so that means that our B value is E, which by the way we just decided was 2.718, blah, 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 blah. So is this going to be a growth or a decay? A growth, okay? So it's kind of a simpler idea because our growth factor will always be the same number, okay? We're only talking about growths in this section, okay? So this kind of takes you through where they came up with the value of E. So if you're interested, you can look at that. But I'm going to scroll down and just go straight into the part where we just get to do the stuff. Did I go too far? I might have gone too far. Whoops. Take it back. I just want to do a graphic one. Oh, I didn't go too far. Good lord. There we go. Whew. Okay. So you need to be able to graph these functions just like you did in the last section. Okay. So I want for you to identify the pieces. I want you to identify the y-intercept, your h and k movement, and well, that should be pretty much everything. Okay, so what does this -1 at the beginning of this function tell you? Y-intercepts, right? Okay, so this is the y-intercept before the translation. Now, it is a negative value. So what does a negative in front of any function tell us also? It's a flip, okay? So it gets flipped upside down over the x-axis. Okay, what about if I have an x plus 2 up in the exponent? What direction does this move? To the left, 2, good, and down 3. Okay, so just like what I was doing in the last section, what is the very first thing I need to draw when I go to graph? The dotted line, right? Okay, so the asymptote, where is that one at? -3. So I draw the little asymptote here. Okay, so now I'm going to start with my y-intercept, and I'm going to move it, my 2 translations, so I'm going to start where? What's my y-intercept? -1. Okay, so I start at -1. Now what are my 2 translations? Left 2, down 3. So everybody land right there?
Yeah.
Exactly at the point -2, -4? Okay, so that, by the way, is our reference point. So when they ask you to come up with the reference points, that's what they're referring to. Okay, now all I have left to do is simply draw this equation. If I have a negative growth, usually it goes up, and I flip it upside down, what's it going to look like?
Go left to right, down, up to down.
Up to down. No idea what you just said, but let's go with that. Okay, so I'm only asking you to find one reference point. We could be more precise and find like y-intercepts or even just another point, but I'm only asking you to do the one. Fair enough? Okay, let's quickly talk about this piece right here. Okay, they're going to ask you to identify those 3 things. So what is the asymptote? What kind of asymptote do I have? Is it a horizontal or is it a vertical? Horizontal, good. So I would say horizontal asymptote at, so if it's at 3, I have to say that as an equation. So instead of saying at 3, I want to say at y equals -3. Okay, so write it as equation. Okay, what's the domain? Okay, so the smallest x value to the biggest can be anything, all real. So you could write that negative to positive infinity, or you can write the cool little fancy r. Okay, what about my range? Okay, so everything below -3, right? So I heard y has got to be less than -3, and I heard from -infinity to -3. Both work. Now, do I include -3?
No.
No, right? Because it never touches it. It's horizontal asymptote. Infinitely close, but never equal to.
Put that little bracket around it instead.
Bracket would mean it's equal to.
Oh.
So pretty easy, right? This is not really new information other than the E part. The graphing is still the same. Okay, they also do the same, just like they did in the last, where here is this equation, or function, come up with the equation for it. Okay, so in this scenario, we know that we have the basic parent function of y equals a times e to the x minus h plus k. Okay, so looking at the graph, what do you know? Okay, the k is 1, right? You guys see the horizontal asymptote that is moved up 1. The k is 1, that's for sure. Okay, so do you see the point that we're going to use as our reference? Yeah, there's a little arrow right there. That blue point. Okay, what's my h?
2.
2, very good. So, because it's moved to the left 2.
Yeah.
Good. Okay, at this point, what's the very last variable we're missing?
A.
The a. Okay, so what we're going to do is we're going to use the other point and plug that into the equation and solve for the a. Okay, so as of right now, I know y is equal to a times e to the x plus 2, right? Plus 2?
Yeah.
And plus 1. So we're looking for the a value. Okay, so at this point, I'm now going to use this point right here as an x, y, and plug that into my equation so I can solve for the a. Okay, so we keep doing this over and over, right? It's in every section, this idea of coming up with the equation. So what's my y value that I'm going to replace? That's the x. 1 minus e. Isn't that the strangest y value? What's my x value? -1. So -1 plus 2, and then I have plus 1. Okay, so I'm solving for a. What would my first step be? -1. So do you see immediately what happens when I subtract 1? The 1's cancel out, right? Okay, so we have, I'm going to write this up here now. Negative e is equal to a times e to the, let's say, what's -1 plus 2? 1. Okay, and e to the first power is still e. So what's my last step here if I have a times e? Good. Divide by e. So what's negative e divided by e? -1. Nice. So my a value is simply -1. Okay, so that makes my equation y equals -1 times e to the x plus 2 plus 1. What do you guys think? Pretty easy. So far, not really any new information. Okay, so this is going through graphing E. I don't think we need to go there. Here's a pretty little word problem about some E stuff. I'm feeling like we got this E thing. Not a lot you can do with the E.
How do you find the reference point with your graphing?
You start with the Y-intercept. So whatever the Y-intercept is, and then you take that Y-intercept, whatever the two translations are. So if it's like left 2, up 5. All right. So the second part, this is compounded interest. This is one of my favorite things to talk about. Because guess what we're talking about? Money, money, money. What'd you say? I know, right? It's so rare that I get to talk about actual real life stuff. I mean, I do, but let's be honest, it's not super. Okay, so here is this idea of compounded interest. Okay, so here is an explore idea. So we have a bond. Anybody know what a bond is?
Yeah, like a bail bond.
Well, not necessarily a bail bond, but
It's like money.
It's money.
it's money that you.
It's an investment that you buy with
Yep.
cash for which
Oh.
you receive.
Yeah, well said.
I just remembered.
I just remembered.
I just knew it was an investment management money.
Yeah, so like you can buy a bond. You can go to the bank and say, I want a bond. I'm going to put $1,000 into a bond, and they're going to say, okay, we'll give you this percent for every year you keep it in there. Okay, so there we go. Here we go. So let's say we're going to take $1,000, and they're going to give us 5% every year. Okay, so what is 5% of 1,000?
2, 20.
Type it in the calculator.
2 or 20. No, it's 20. I'm pretty sure it's 20.
Did you type it in?
It's 20.
1,000 times 0.05.
Oops. Site.
50.
Oh wow, this is a tough question.
Oh, no.
1,000 with 3 zeros times 0.05.
It's 50.
It's
Oh, I
50.
guess I could have just moved the decimal place over.
Yeah,
Yeah, that would be wrong.
thought you were.
Like
Okay.
4.
So if I earn $50 on 1,000, how much do I now have? 1,050, right? So after 1 year, I now have, whoops, I wrote that wrong. $1,050. Okay, on the second year, I'm going to earn another $50. So now how much do I have? 1,100. Then I earn another 50. Another 50 and another 50. Okay. So we could go through and like do this over and over and over. Like what if I said, how much are you gonna have after 20 years? Do you think you want to do this little table with 20 years on it?
No, it's.
Nah, that wouldn't be very fun. So there's like an equation. Okay, so here's another situation. I don't know why we really had to go through that, but here we go. So here's the equation you should write down. Compounded interest. Is everybody writing this down in their notes? Write it. Right. Use your pencil or your pen. Maybe a highlighter. Okay, so I don't know why they use V. That's a strange variable to use.
P?
V. I know why they use P, but I don't know why. Yeah, the T is up in the exponent. So the P, does anybody know what P stands for?
Like principal.
Principal. Very good. So what is the principal?
The amount invested.
Very nice. Okay, so if you didn't know that, write that in your notes. Principal is the amount that you invest, or maybe you're taking out a loan, so maybe you're borrowing. But anyways, your pull. The PAL is your
Person that runs the principal.
school. Paul.
P-R-I-N-C.
Is the person that runs the school?
Principal. P-A-L.
Is the person who runs the school?
Yes.
Yes.
So there's only one principal.
No, there's a P-R-I-N-C.
This principal is P-L-E.
E-L-E?
Yeah.
What would that be?
That's like, yeah,
Like a principal?
like, yeah, principals.
Okay.
Think about.
All right, what does the R stand for now that we've Googled all the words for principal?
Reject.
The
Like the amount,
you know, like
the amount you get back. Like,
return.
Return, no.
Rate.
The rate, there it is, the rate. Okay, how much are you earning? 5%?
Do it.
2%? What does T stand for? Time. Okay, and by the way, this is only for years. It'll change if you're doing it monthly. No. No.
I never understood that in 8th grade. So.
Well, we're not going there today.
I almost failed 8th grade because of that.
Wow, that's
My mind didn't
highly
make,
weighted.
it didn't make sense. Our final was measured at this straight time, like 3
Oh.
in a row. Oh, yeah, I remember that.
Okay, so here is a scenario where we have an investment of $3,500 and we're going to earn 3%. So this is like a complete real world scenario, right? By the way, while we're talking about money and investments, how many of you guys have a checking account?
It was a no.
Plan to have a checking
I
account
have a
someday.
checking account.
Does anybody know what the rate is for a checking account?
1%.
Less than that.
0.01.
Yes.
Yeah, I knew it. I knew it was one of them.
0.01% on a checking account, which is like, might as well be 0%, let's be honest.
For real.
Okay, what about a savings account?
5%.
No, it's
1%.
like 0.02%. So it's like a little bit better than 0.
Well, I just put in $500 in my savings account last year, and it's got like $503.
Wow.
Whoa!
$503. That's huge. Nicely done. So, what else can you invest in at a bank?
What actually?
What can we invest in?
Yeah, do you know what else you can invest your money in at a bank?
Ooh,
Other banks?
stocks is dangerous though.
No, stock
Okay,
market's nice.
stocks,
No, it's
you
not.
can invest in stocks, but those are not through a bank.
Yeah, that's like.
What if I invest in a bank like Wells Fargo?
I'm not sure if you
I have stocks in
can.
Wells Fargo.
Do you?
Yeah.
Okay, well you're investing in the stock market.
Yeah.
Do you invest in
Stock
I have
market's
stocks in
dangerous.
Wells Fargo.
Business, a journal business.
All right. Anyways, so the answer to my question, by the way, was a CD. Have you guys ever heard of a CD?
Yeah, like the one that you put-
Certificate of deposit. So a CD would be something like this, where you can say, I will give you $3,500 for 5 years, and they will give you a percent closer to 1, 2, or 3%, depending on how much money you give to them and how long. So those are pretty good investments. They're very safe. You always get your money back. But you can't take them out. If you say, I'm going to give this to you for 5 years, you have to leave it in there for 5 years. Okay, so let's set up this equation. What is my principal for this? Yep.
That's the amount invested. So
Okay.
3,000.
What?
Am I looking at 3,500?
Yeah, I literally said.
Okay, so then 1 plus R. What is my R?
R is point.
Okay, so 0.03. You're slightly ahead of me, I think. The T. And so 10,000 is going to be what?
Oh yeah.
What it's equal to. Okay, so we have to figure out how long it takes to get $10,000. Okay, so if I simplify this just a little bit and try to solve for my T, I could say, well, 1 plus 0.03 is 1.03. Okay, then what would you do algebraically to solve? Okay, you can't multiply, remember, because it's 35 times 1.03 to the T, so how can we get rid of the 35? Yeah,
Wow.
so get rid of this by dividing. So help me out, you guys have a calculator. What's 10,000 divided by 3,500?
Like 2.4 something. Something like that. 2.85.
2.856? 7? Okay. All right. So at this point, this becomes an equation that you guys cannot solve at this point in time. It's absolutely solvable algebraically, but you haven't been taught that method yet. I hope to get to it next week. But at this point, you can't do it algebraically. So what we're going to do is we're going to solve it graphically. Okay, we are going to set the two equations equal to each other and see where they cross. Okay, so grab your calculator. Okay, you can do this in Desmos or you can do it in the 83. Just remember, you can't use Desmos on the test. Okay, so you need to know how to do it on the calculator. What's that? Because it's on your phone. If I could mandate exactly what you were doing on your phone, then that would be fine. If you were just using Desmos, I'd be okay with it, but let's be honest, that's just not going to happen. Yeah. Alright, so I'm going to put one side into my y1, so I have 1.03 to the x in my y1, and then I have the other side in my y2. And then one calculator. Okay, So once you have this in, hit a zoom 6, so you have a standard 10 by 10.
Second.
2.857.
Is that it?
Okay, so yeah, just that straight line. Did they cross in our window?
Go with it, Will.
So you gotta go
Right.
window.
Okay, yeah, so I have to hit window, and all I basically need to do is go further to the right, right? So that's an X max. So what do you think the X max might be? How far over should we go? 100? Wow, 100 is big. Okay, let's try it. Okay, so there's my super slow exponential equation.
Whoa.
And there's, perfect. Okay, so that's in the window. So then I hit second trace, and I hit number 5 for the intersect, and you enter, enter, enter.
Wait, what do you do?
Second trace, number 5, and then enter, enter, enter. So what's the X value that I get?
35.5.
35.5. Okay, so that's my answer. Shh. 35.5 years is my answer. So we're only looking at the X value on the calculator. 35 years to get that at 3%. It's kind of sad. Barely double. So for $3,500 to turn into $10,000. Slightly over double. Takes 35, 3%. So kind of goes to show how important the rate of your investment is. All right, how do you guys feel about this? Do I need to do another one of these problems?
Sure.
Do one more? Okay. So this will be the last one, and then you guys can get a little break. So a person invests $1,000 at 5.5%. That's better.
Yes.
How long is it going to take for it to double? Okay, so what's my invested amount? $1,000. So then I'd have 1 plus my rate. So what am I going to use? So remember, you have to convert it 0.055 to the t, and what's that going to equal? So if it's doubled, how much is doubled? 2,000. Okay, so I'm going to simplify it real quick. So 1,000 times 1, point 0.055 to the t equals $2,000. Then what? Divide by 1,000. So we got 1.055 to the t is equal to 2. Okay, so now I'm going to go to my calculator. 1.055 to the x. Oh my gosh, that didn't look right. So I'm gonna make my thing bigger. There you go. And then my y2 is just 2, right?
12.
Wow. Did you just hit graph off that and keep your big giant window?
Yeah.
I did. Jesus.
Okay, so as long as I can see the intersection in my window, I'm okay. I can hit second, trace. I can move it off of the little. Okay, number 5. Enter, enter, enter. 12.9. Is that what you got? 12.9? Years. Yeah, that's a lot better. All right, we good?
Yes.